Sample problems, 5-2, day 1. Going to get a little bit more challenging, but as long as you understood the basic concepts in the pre-lesson, you should be okay. Remember, this is Algebra 2, not Algebra 1, so they're going to really crank it up on you. So just remember, this is all built on the basic rules. You just have to see it, okay, and get a little creative. So here's your math problem. Well, what's this even asking you to do? Recognize that we have common bases, and we're multiplying, so the base doesn't change. We just need to add the exponents. We're like, dang it, we got to find common denominators. So, well, I'm going to change this to tenths, so that's 6 tenths plus a negative 1 tenth, which is just the same thing as 6 minus 1, which is 5 tenths. Well, what does that reduce to? 1/2. You see, these math authors really know how to make problems work out if you just follow the right steps, because I look at this and I say, hey, that's the same thing as the square root of 32. Remember what I said, it's okay to break these down if there's a large perfect square root that goes into 32. And that's 16. How many times? 2. Now what if a student said, well, 4 goes into 32? Well, that would work, but I'll get to that in a minute. This one's better because I found the largest. So that would just take me to 4 square root of 2. What if a student went this way? They'd go 2 square root of 8, and the danger is they'd go, good, I'm done. No, because the square root of 8 can still keep going. Better pause this. So back to this, sorry about that. Get to here, square root of 8 would break down into the square root of 4 and 2, water. There's some oil, but look at the square root of 4, miraculously goes from water to oil. And then I get 4 square root of 2. Same thing, a lot more work. So be patient, try to find the largest perfect square root or cubic root or fourth root, save you time in the long run. Different looking problem. Right here, got the fourth root of 81, blah, blah, blah. Let's chop down one tree at a time. Like, ooh, is that a perfect fourth root? Well, it's an odd number, so I'm going to take a stab that 3 goes into that, and let's test it. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So yay, the fourth root of 81 is 3. Now we're going to go to this method. A, power over index, and go over here. B, power over index. You can see that this one cleans up, so that turns into 3a squared. Now what in the world do we do with that b to the 5/4? If they say leave it in exponential form, you're good. But they're going to say get it in simplest radical form. That's what they mean when they say rewrite it. So we got a situation here. So we got to use some common sense. This is the same thing now as the fourth. You can look at it 2 ways. We can break that up into b to the 4/4 times b to the 1/4. Kind of like this rule in reverse. I'm just taking this and breaking it up into 2 things that add up to 5. I'm taking the 5/4, I'm breaking it up into 2 things that add up to 5/4. And I lop that off because I know that's going to turn into a 1. Then this is just the fourth root of b. Now there's a 1 there, so there's really a 1 there. Now I've got oil and water, so this oil joins the other oil. The water is this. Don't forget that little 4. If you forget that, you completely change the value of the problem. The other way to look at this would be to go, okay, that's the fourth root of b to the 5th. Now remember, when we do the square root of 27 and problems like that, we break off the largest perfect square root and then whatever's left, which is 3 square root of 3. If we think like that, I could break this up into 2 pieces. What's the first number less than 5 that 4 goes into evenly? That'd be 4. and then I'd have 1 left over here. Now what's 4 divided by 4? 1. So that's b to the first times the 4th root of b, which is the same thing as I got here, a little different strategy. Next problem. What a mess. First thing I would do is I'd say, okay, take a look. There's a little oil. It's there, but it's not, you don't need to write it. And there's some oil. So let's combine those two things. So that's 1 times 2 is 2. And then, remember, if these are the same, we can multiply the stuff underneath here. So 2 times 2 is 4. P times p cubed is p to the 4th, because there's an invisible 1 there, and I add the exponents. Q, there's a 1 there and a 6 there, so that's q to the 7th. Now if I go 1 tree at a time, there's no way I can break that down. So that is just stuck underneath there. There's a perfect square root of 4, but not the 5th root. So now I'm going to start looking at the 5th root of p to the 4th. Now notice, this is less than 5, so that's stuck. There's no way I can break that up into little parts and reduce it. This is greater than 5, so I'd say, okay, there's a little bit of work to be done there. And remember, if you have a situation like this, ask yourself, what's the first number less than 7 that 5 goes into evenly? Well, that would be q to the 5th. And then, what would be left? Q to the 2nd. So what is this? Well, 5 divided by 5 is 1. So that would just be q. And now this would be considered oil. So I put it with the 2 here. So 2q, 5th root, that was there, and this thing's stuck now. So that's q squared. Done. A little different problem. Notice we've got a denominator and a numerator. Chop down things one at a time. Now, I'm going to show you things that you need to be on the lookout for. So, what I call this, I call them Christmas gifts, and you need to be on the lookout for them. You know, you got Christmas presents around the Christmas tree, it's got your name on it. You wouldn't go, nah, you go get it. So where's the Christmas present? Well, here's one. The cubic root of 125 is just 5. So I know in the denominator a 5 pops out. But then there's another little sneaky thing. It's kind of like PEMDAS, where if I had a fraction and I had it like this, 7/14, I should go, aha, that reduces to 1/2. Well, if you remember a rule back in Algebra 1, if you have something like this, I'll just make it up, x to the 7th over x squared, you would subtract the bottom from the top. So this would actually be x to the 5th. And if I look at this, it's 4 and a 1. So what's 4 minus 1? That'd be 3. But that would be in the top. And then I'm left with y squared here. So a little math trickery right there. You just got to be on the lookout for it. By those two things reducing, this problem just got a lot easier. Because look at, there's another Christmas present. What's the cubic root of x cubed? That would just be x. Cubic root of y squared. So that's what I have at the top, and this is what I have in the bottom. If this number is smaller than that number, there's really no more simplification possible. All right, the instructions on these problems are write it in reduced radical form, which means just do what we've been doing. Previous problem had some Christmas presents. This doesn't. You just got to work it out. There's no real perfect. Oh, wait a minute. I think there is a 5 in the index. Yep. So that is a real pain. If there wasn't a 5, then it'd be the square root of 16. It's 4. That's a Christmas present. But this is a 5. Now, we don't care about the numerator unless it can be simplified, and that just can't be simplified. The denominator, we have two problems now. We got the 5th root of 16. I want you guys to think about this. 2 definitely goes into 16, but if we go 2 times 2 times 2 times 2 times 2, remember, 5th root, I want to go 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So what I want to create is this, because the fifth root of 32 is 2. So what I'm going to do is I'm going to multiply this by the fifth root of 2, and I got to do the same thing to the top, because what's 16 times 2? Well, that is the fifth root of 32, which is 2. So I got the radical out of the denominator as far as the number goes, so there's a 2 there. Now the top, because this is water, water, fifth root of 14. I'm not done yet. I still have this x cubed in the bottom. So what I'm going to concentrate on is the fifth root of x cubed. Now remember, we got to get the radical out of there. So we're going to be creative. Isn't it true that the fifth root of x to the fifth is just x? So what I'm saying to you is, you got to create this in order for the radical to disappear. So I need x to the fifth. So what am I going to do? I'm going to add 2 of them to the bottom, but if I do that, I got to do that same thing to the top. So the top is going nowhere, so I can just put that right up here in my answer. The bottom turns into, remember, if I multiply and have common bases, I add the exponents. So 2 plus 3 would give me my 5, and then 5 divided by 5 is 1. So that's why I'm able to say I'm done, because I got the radical out of the denominator, and this is reduced radical form. Nothing else you can do. Here we go. All right. Hey, we got the fourth root, fourth root. You know what that means? You can multiply those together. These are way easier than those ones that have denominators. So we're going to multiply that all together. 27 times 3 is 81. There's an invisible 1 there, so I add the exponents, and I get x cubed. I'm done. No, 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 no. I know you guys are used to the square root of 81 being 9, but that doesn't say the square root. It says the fourth root of 81. So this is an odd number, so I'm going to start with this and just hope that this equals 81. Well, that's 9 times 9, which is 81, so we're happy about that. So that 81, fourth root of 81 is 3, and that thing is stuck, because that number is lower than the index. You'd be done. Last problem of the sample problems, right here. This one, we've got to remember PEMDAS, which means parentheses, clean up anything inside that you can. There's nothing to clean up, nothing that reduces. So then I go to exponents. Now I know there's an exponent here, here, and here, but this exponent is talking about this one, so you ignore it, because this exponent only applies to things in the parentheses. So let's just take care of this. 2 squared is 4. Power times a power, or power to a power, means multiply, and 1/2 times 2 is 1, and then I get this 1/3 times 2, which is 2/3, and that is times 3x to the 1/2. Now, you guys are used to problems like this because you've been doing them forever, and you distribute, so you might think about doing that, but that's not the time to do it. This is like 3 times x times 2. It's just mash it all together, which is just 6x. See, these are different problems. We have this situation going on here. So you mash them together, you get 12. Now, there's an invisible 1 here. So I get x. Now, what's 1 plus 1/2? Well, you might say 1.5. Don't you dare introduce decimals. 1.5. Don't you dare use mixed numbers. So 1/2 plus 1 is the same thing as this, which is 3/2 c to the 2/3. You're done if they say leave it in simplest exponential form. I got to hurry here, but they don't. They want it in radical form. So this is 12 times the square root of x cubed. Uh-oh, I better pause. Cramming this in. This turns into this, because this breaks down to this breaks down to this, and then my answer would be that. I think I got it in, barely. Sorry about that, you guys. Better than making a whole new video.